10 to the power of 100 is a Google. 1000 to the power of 100 equals. Google, of course, is our famous search engine, spelled slightly differently. And Google started in 1998. The internet began in Canada in 1994. Yahoo, if I remember, started in 1995. Now, what's interesting is, when I first learned the internet in 1994, there was no Yahoo, no Google. So what search engine did I use? Lycos. Most of you watching this video have never heard of Lycos. I think Lycos still exists if you go type it. And there was another one called Alta Vista. These are search engines that existed way back in 94 when I was in undergrad. And it's amazing how Google came along actually a little bit later, but then eventually took over the entire world. And Google bought YouTube, and the whole world is on YouTube. It's actually the #1 most visited website on the internet. All right, going back to the question, we've got 10 to the power of 10 is equal to a Google, right? So we want to figure out 1000 to the power of 100 in terms of a Google. Okay, no problem. The 1000 here I can write as 10 to the power of 3, like that. All to the power of 100. So this becomes 10 to the power of 300. And then I can factor that again as 10 to the power of 100, all to the power of 3. Just rearranging the numbers. Now 10 to the power of 100 is our Google, and that's all to the power of 3. So there you go. Number 17, therefore, the answer is E. What is the largest integer, n, for which 3 times n to the power of 2007 is less than 3 to the power of 4015? 3n to the 2007 is less than 3 to the power of 4015. Well, the first thing I'd like to do is get rid of this 3 here. And I can do that by breaking up 4015 into 1 and 4014. It's perfectly allowed to do that. And if you do that, you do indeed get rid of those 3's. So now you're just left with n to the power of 2007 is less than 3 to the power of 4014. Now, 4014, I immediately notice, is exactly double of 2007. So I can write 3 to the power of 2 all to the power of 2007. That is perfectly allowed. And this is n to the power of 2007. So n to the power of 2007 is less than 9 to the power of 2007. So there we go. This is what we've boiled it down to. And if you stare at this, the largest value for n, well, n obviously is less than 9. So the largest value of n less than 9, that is an integer, is n equal to 8. So number 20, the answer is D. For how many integers n is 72 times 3 over 2 to the power of n equal to an integer? 72 times 3 over 2 to the n. All right. Let's break up 72 into its prime factors. It's going to be 2 times 2 times 2 times 3 times 3, 3 over 2 over n, like that. So this is 2 to the power of 3 times 3 to the power of 2 times 3 to the power of n divided by 2 to the power of n. Combining, we get 3 to the power of 2 plus n times 2 to the power of 3 minus n. Okay, so like I tend to do, I will make a table, and let's see what we get. So here I will put n. Here I will put 2 to the power of 3 minus n, 3 to the power of 2 plus n, and then of course the product, which is 2 to the power of 3 minus n times 3 to the power of 2 plus n. All right, here we go. So the first thing, of course, is where do I start? Obviously, I made a table. I've got to start somewhere, end somewhere, but where do I start? Do I start with 0? Do I start with 1, 2? Well, we quickly look at these two guys and realize for this guy, if I start with, say, 1, I can keep going forever, right? It's always going to be an integer no matter what I put. Whatever positive number I put for n, it doesn't seem like there's any kind of limit. But with this one, it does seem to have a limit. If I put 3 for n, the exponent will be 0, which is fine. But if I put something greater than 3, the exponent will start to become negative. So for example, if I put 4, 2 to the power of 3 minus n will become 2 to the power of negative 1, which is a half. This 3 to the power of 2 plus n will be 3 to the power of 6, which is fine. But when you multiply them, you will not get an integer. You'll get like 364.5 or something. So as you can see, the problem occurs when n is greater than 3. And in particular, it's with this guy. So I have to keep my n less than or equal to 3. So let's do that. Let's put 3. If I put 3, this becomes 1. This becomes 3 to the power of 5. And when you multiply them, it's 243. That's an integer, so that's good. When n is 2, this becomes 2. 3 to the power of 5. This is 162. When n is 1, this becomes 4. This is 3 to the power of 4. The product will be, sorry, that one was 3 to the power of 4. This is 3 to the power of 3. And the product will be 108. When n is 0, we're going by integers, of course. 8, 3 to the power of 2, which is 9, and that's 72. When it's negative 1, it will be 16. This will be 3. The product is 48. When we have negative 2, we will have 32. This will be 1. Product is 32. When this is negative 3, we will have 64. Now we get 1/3, and this will be 21.33. And as you can see, we are now no longer going to get integers. So we got integers here, 1, 2, 3, 4, 5, 6, for the corresponding values of n. And those are these guys. And there's 1, 2, 3, 4, 5, 6 of those. So 6 values of n make this expression an integer. Therefore, number 20, the answer is E. If w is a positive integer and w to the power of 3 is 9w, then w to the power of 5 is. W to the power of 3 is 9w. So divide both sides by w, and that leaves you with just w squared is equal to 9. Take the square root, and you get w is equal to 3. And they tell you that it's a positive integer, so it can't be negative 3. And then now we just figured out w to the power of 5. Well, w is 3, so 3 to the power of 5. And 3 to the power of 5 is equal to 243. So number 17, the answer is B. 2 to the power of third times 2 to the power of 2 times 3 to the power of 3 times 3 to the power of 2 is equal to. All right. So we obviously have to sort of combine this, because I looked at the answer choices and see the bunch of 6s here, and I see 36s. So they've gotten rid of the 2s and 3s somehow. Well, the rule is that if the exponents are the same, you can combine the bases. So I can combine these two as follows. And if I combine those, I get 2 times 3 all to the power of 3, like that. And very similarly, I can combine these two because they have the same exponents. So again, 2 times 3 all to the power of 2, like that. So this becomes 6 to the power of 3, and this becomes 6 to the power of 2. And then, of course, I can add those exponents, and that becomes 6 to the power of 5. So number 13, the answer is A. If 2 to the power of n is equal to 8 to the power of 20, what is n? 8 is 2 to the power of 3. And therefore, using the standard rules for exponents, you would multiply, and that would be 2 to the power of 60 is 2 to the power of n. The bases are the same, so that means the exponents are the same. N is 60. Number 13, that's B. The expression is equal to 3 to the power of 2011 plus 3 to the power of 2011 all over 3 to the power of 2010 plus 3 to the power of 2012. Okay, we have to factor. The largest factor that exists in every expression is 3 to the power of 2010. If I do that, on the top I get 3 to the power of 1 plus 3 to the power of 1. In the denominator, if I factor out a 3 to the 210, I get a 1 plus 3 to the power of 2. These guys cancel, and all I'm left with is 3 plus 3 over 1 plus 9, and that is 6 over 10. In lowest terms, that is 3 over 5. Number 17, therefore, the answer is A. The value of 11 over 12 squared is 11 over 12 is 121 over 144 when you square it. And that is approximately, in terms of decimals, about 0.84. And now we just have to identify which range is this in. 0.84 is obviously between a half and 1. So number 13, the answer is B. There are two ways of choosing 6 different numbers from the list 1 through 9, so that the product of the 6 numbers is a perfect square. Suppose that these two perfect squares are m squared and n squared, where m and n are positive integers and m does not equal n. What is the value of m plus n? Let's break up each of those numbers into its prime factors. So instead of 4, I write 2 times 2. 5, instead of 6, I write 2 times 3. 7, 8 is 2 times 2 times 2, and then 9 is 3 times 3. So we have to choose 6 numbers, and then in the end, that's got to be a perfect square. Okay, so this is going to be a little bit of an experimentation here. The first thing that we have to understand is that whenever you put numbers together, they've got to match up. So it's got to be 2 squared, or 2 to the 4th, or 3 squared, or 3 to the 4th, or like that. You can't have 2 by itself, or 2 to the power of 3. The exponents must be even. That's the only way you can get a perfect square. So that's very, very important to understand. So there's no way you can do that with the 5 and the 7, because there's only one 5 and there's only one 7. So 5 times 5 would not be possible. 7 times 7 would not be possible. So these two are duds. They're not going to help us. So we can only concentrate on 1, 2, 3, 4, 5, 6, 7. So we have to choose 6 from those 7. All right, let's experiment and see what we get. So I'm going to start off with this guy, 3 times 3. Okay, that's pretty good. Let's see here. I'll put in this 2 times 2. So far, I'm choosing perfect squares. Might as well put in this guy, 2 times 3. But then I've got to match them, remember? So I'll put a 2, and I'll put a 3, and then I'll stick in that 1. This gives me 3 to the power of 1, 2, 3, 4. And it gives me 2 to the power of 1, 2, 3, 4. Okay? When you do the math, that is actually equal to 36 squared. And therefore, that will be my m squared, where m is 36. All right, so I got one such value. Now we do the exact same thing again, and hopefully we will get another value. Let's use a different color. All right, so I basically, it's kind of interesting that there's only 7 choices. 1, 2, 3, 4, 5, 6, 7, right? And in the first one here, I chose 6 of those 7. The only one I didn't choose was this guy. So obviously, in order to have a different number, I have to choose that one. So 2 times 2 times 2. Okay, so I took care of that one. Now, I guess, I've got to experiment, figure out, there's only one that I'm not going to choose, right? Because I have to choose 6 of the 7. Okay, well, let's see. If I'm wrong, I can always retrace my steps. Choose this guy. 2 times 3. I'll choose this guy. I'll choose that 3 in there. So my 3's match up, and so will do my 2's. So that's great. And then how many got? 2 more, right? Well, the only way is to put 2 times 2, and then to put the 1. So this was the only one not chosen this time. Okay, so this is 1, 2, 3, 4, 5, 6. 2 to the power of 6. 1, 2, 3, 4. 3 to the power of 4. Great. This is, if you do the math, 72 squared. So therefore my n is 72. So there we go. I got an m, I got an n. Now I just have to add them. And when you do, you get 108. So number 19, the answer is A. A piece of paper is folded in half, creating 2 layers of paper. The paper is then folded in half again. This is continued until the paper has been folded in half a total of 5 times. Total number of layers of paper in the folded sheet is? Well, we have fold 1 all the way up until fold 5. When you fold the paper once, it makes 2 layers. When you fold it a second time, it doubles the number of layers. So 4. Then you double the number of layers with the next fold, 8. Doubling again and doubling again. And if you're not convinced of this, just take out a piece of paper and do this, and you'll see. So after 5 folds, we've made 32 layers. So number 12, the answer is B.